Okay, so today we're going to be talking about radicals. Now, for those of you that don't know what a radical is this symbol right here. It's taking the square root of a number. So a few examples that we have here are the square root of 25. So when you take the square root of something, you got to think of if you were trying to solve x squared equals, let's say, a. How are you going to solve this? To get rid of the squared in here, you want to take the radical of it. You want to take the square root of it. You want to take the square root of a. So x here would equal the square root of a. Now when we're looking at the square root of 25, we know that 5 squared, 5 times 5, would get you 25. So the square root of 25 is 5 because 5 squared equals 25. Now this number inside the radical actually has a name. It's called a radicand. Okay? So now looking at the next one, we're looking at the square root of 64. So you want to think what times what would get you 64. And then the square root of that is that answer. So you could think 6 times 6, 7 times 7, but it's 8 times 8 that's going to get you 64. Now a little bit bigger, 100. You got to think, okay, what squared is 100? And the square root of that is going to be 10. Square root of 36. I'll give you guys some time to try to do these last two on your own. Think about the square root of 36, square root of 4. You could pause the video and give about 5 seconds of silence here for you to do the next two. Okay, whether you pause the video or you were able to do it in that time, the square root of 36 is 6. The square root of 4 is 2. So when you look at all of these, when you look at square root of 25, square root of 64, these all came out nicely. You get 8, you get 10, no decimals, no nothing. Why wouldn't I show you, for example, the square root of 24? What's the square root of 24? It's not going to be a nice, easy number like this because anything times anything is not going to get you this radicand of 24. So the square root of 24 is not going to be a nice number. These numbers where it's multiplied by itself, these are called perfect squares because they line up evenly. So square root of 36 can be 6. Another example that's not on here would be the square root of 16. The square root of 16 is 4 because 4 times 4 equals 16, right? So the definition actually of a perfect square is the product of a positive rational number multiplied by itself. So if you don't know what rational means, we're going to cover that actually in a later lesson this week. We're going to go over a bunch of different types of numbers in the number system. But right now what you want to concentrate is the product of a positive rational number multiplied by itself. So why is it called a perfect square though? This actually has a name for a reason. It's because when you look at the area of a square, it's going to be length times width. Well, since it's a square, what we know about squares are all sides are equal. So the length times width is actually just going to be x times x. X is going to equal x here, obviously, same variable. So that's how it came to be a perfect square. Even though this doesn't look perfect, I know this is drawn out. The area of this is 16. So what would x be? I want you to think about that real quick. How can you find x? Well, as I mentioned before, the square root of 16 is 4, right? If x is 4, 4 times 4 is going to get you this area. So 16 is once again another example of a perfect square, like 25, like 64, like 100, like 144, right? Back to what I was saying earlier, not all radicands are going to be perfect squares. So when you square root something like 27, you actually have to break down this number inside in order to simplify it. So you could start thinking, okay, what times what gets you 27? And most what I think most of you is going to think what times what is going to get you 27 is probably 9 times 3, right? So if you have 9 times 3, now we look at 9 and 3. Are either of these perfect squares? Well, 3 isn't, because nothing times there's going to be nothing times anything that's going to get you 3 if that number's the same. There's going to be no two numbers multiplied together that's going to get you 3. But there is a number multiplied by itself that's going to get you 9, and it's actually 3. So when you break this down, you could cancel out this 9. This isn't going away. This is not going away. That's not what this means. This means that we have a perfect square, so we could forget about this being a radicand anymore. And now 3 is going to be your only radicand. So outside of it is going to be what the square root of 9 is. And it's a nice, easy 3. So to simplify the square root of 27, you don't just give up, or you don't just put a decimal, or you don't try to figure out the fraction of it, or whatever it might be. You could just simplify it into what this is called the simplest form. I want you to remember that, simplest form. The simplest form of the square root of 27 is 3 root 3. Let's try another one. How about 50? So what can 50 be broken up into? We could say it's 5 and 10, right? But both 5 and 10 aren't perfect squares. You want to be looking for your perfect squares. Okay? So we're not going to be looking at it like that. Think about what has a perfect square in here. And if you've already thought about it, 25 times 2 equals 50, right? So this square root of 25 times 2 is the same thing as the square root of 50. We're just breaking this down. And you could obviously remember from the beginning maybe, the square root of 25 is a nice easy 5. So this is going to be 5 root 2. I want you to try to do 72 on your own. 72 is a little bit of a tougher one. You could either pause the video, or I'll give you a couple seconds to try to think about what the square root of 72 might be. Okay, whether you paused it or not, coming back, and I'm sure that most of you might have thought, okay, well, 9 times 8, right? 9 times 8 is 72, right? And then you thought, okay, it's 3 square root 8. The problem with this here is this is not simplest form. Because if you look at this, 8 could be broken down into 4 times 2, and now you have another one right here, another perfect square, 4. And if you would have to bring that out, and this would equal 3 times 2 times 2, which is equal to 6 root 2. Which is your answer here. This is the correct answer. But how I want you guys to be, or what I want you guys to be looking for in these, is the perfect squares that go with it. So if you thought a little bit more, instead of going this way, we're going to veer off and go this way. Think about what 6 squared is. It was 36, right? 36 times 2 is 72. So check all of your perfect squares that are less than the radicand in here before you start doing this, so you don't have to do as much work. If you would have gone through them, thought 4 goes into 72, still not high enough. We could do 9, still not high enough. And then you keep going, you would have got to 36. 36 times 2 is 72. So you could have just said, right here, okay, here's your perfect square, 6 root 2. Now, you get the answer either way, it's just one is a lot less work, and it just takes a little bit more mental math to figure it out. Now, the square root of 10. This one's kind of a tricky one, because the only thing that you could use is either 10 and 1, 10 times 1 equals 10, or 5 times 2. Well, 10, 5, 2, and 1 1 is a perfect square, but that's not going to help you. You're just going to get a 1 on the outside, and it's going to be the same thing. 5, 2, and 10 are all not perfect squares. So the square root of 10 is actually just the square root of 10. This can't be broken down anymore. This is in simplest form. Now here's a little bit of a more tricky one. This isn't a number, this is just a squared. But you got to think about when it comes to your perfect squares. 10 is 10 squared. 100 here is 10 squared. When we square root it, it gets rid of this, and that's how we get the 10, right? So here, a squared, the square root of a squared, since a is a times a, you're getting rid of 1 by square rooting it, and this is just going to be equal to a. So you want to remember that when it comes to your variables and your letters squared. That's all I have for today. Now, when you're doing the homework, I'm going to suggest the way that I uploaded the PDFs to you guys, it's kind of on a more grayer paper. So if you print them all out, it's going to take some ink to get this a little more gray, and you'll see it if you print it. You can print it out if you have enough ink, enough black ink to do it. You could just print it out in black and white. It'll be nice and easy. But I suggest that you, instead of printing it out and doing the homework on a sheet, you could just do it in your notebook. Say number 1 is this, number 2 is this. That's fine. Send it in like that. It might be a lot easier. It won't waste your ink or anything. But make sure you show the work. Do not just give me the answers. I want to see the work. I want to see you breaking this down into 5 times 10 or 25 times 2. All right? Good luck.